Publications bias in meta-analysis. Publication bias refers to the tendency for studies with positive or significant results to be more likely to be published, while studies with negative or non-significant results may be less likely to be published or cited. Let's learn about publication bias and related issues. Funnel plot. The issue of potential publication bias in a meta-analysis is another area to consider. There are several ways to detect publication bias, such as using a funnel plot, which is a simple graphical tool that gives an overview of the effect size distribution and can detect publication bias. Steps to draw a funnel plot. The basic steps to construct a funnel plot are as follows. First, calculate the effect size for each study in the meta-analysis and plot them on a horizontal axis. The effect size is typically represented by a standardized metric, such as Cohen's d or Hedges g. Cohen's d is calculated as the difference between the means of two groups, divided by the pooled standard deviation. Hedges g is similar to the Cohen's d, but it includes a correction factor to adjust for potential bias when the sample size is small. Both Cohen's d and Hedges g are used to represent the magnitude of the effect being studied, with larger values indicating a stronger effect. Next, calculate the standard error of the effect size for each study and plot it on the vertical axis. The standard error is a measure of the precision of the effect size estimate and reflects the variability of the effect size estimate across studies. The resulting scatter plot should resemble a funnel shape if there is no publication bias. Studies with larger sample sizes and more precise effect size estimates will be clustered closer to the average effect size, while studies with smaller sample sizes and less precise estimates will be more spread out. If there is publication bias, the plot may be asymmetrical, with fewer small studies reporting null or negative results. When conducting a meta-analysis, it is important to examine potential publication bias, which is the tendency of studies with significant results to be published. To detect publication bias, several statistical procedures can be used. These include subgroup comparisons. Comparing the results of published studies with those that remain unpublished can help detect publication bias. If published studies have significantly different effect sizes compared to unpublished studies, this may indicate publication bias. Begg and Mazumdar's rank correlation test. This test examines whether there is a correlation between effect size and sample size. If there is a significant correlation, this may indicate publication bias. Cumulative meta-analysis. This involves plotting effect sizes against the order in which studies were published. If the effect sizes become smaller and less variable as more studies are added, this may indicate publication bias. The trim and fill method. This involves inputting missing studies to create a symmetrical funnel plot, which is then used to estimate the effect size. If the estimated effect size is significantly different from the observed effect size, this may indicate publication bias. Eager's regression test. This examines the association between effect size and standard error. If there is a significant association, this may indicate publication bias. Failsafe N. This estimates the number of non-significant studies that would need to be added to the analysis to make the overall effect size non-significant. If the failsafe N is large, this may indicate publication bias. Selection models. These models estimate the effect size for a hypothetical set of studies that includes both published and unpublished studies. If the estimated effect size is different from the observed effect size, you guessed it, this may indicate publication bias. However, it is suggested to avoid potential biases in the analysis. it is recommended to use multiple tests and procedures to examine publication bias, known as the triangulation approach. In the next section, we're going to learn about primary analysis in meta-analysis, which includes decision about two different types of model: fixed effect and random effect models.